What's good, everyone? Today we're going to be revisiting the SageMaker Inference and Hosting series. And that's because we have a few more concepts that we want to cover in this feature, along with some more newer features and launches that we'll talk about later on in the coming days and stuff. But something I want to revisit, right? And this is a common integration that's often used in real-world applications, and I thought it would be handy to kind of discuss it on this channel, and that's returning the infrastructure as code. In this series, we've obviously talked about CloudFormation. I think that'll be the previous video in this playlist. But there's also other infrastructure as code options. What we'll do quickly today, right, is we'll overview what IaC is, just briefly. But if you want like more of a rundown, maybe go to the CloudFormation video there. But then we'll introduce the new concept that we're talking about, which is Terraform. And Terraform is another IaC option that's very, very popular and industry standard. And you might know it from the company HashiCorp. And what we'll dive into and understand today specifically, right, is how can we deploy SageMaker Real-Time Endpoints. If you remember, the first example we had in the series was taking a pre-trained scikit-learn model and deploying it on a SageMaker endpoint, and we first did that in a Jupyter notebook. Now we're going to use Terraform to kind of take those same constructs and theoretical concepts that we learned and just do it via this IaC option, just so you have an understanding. If you're ever working with SageMaker endpoints and you have to use Terraform as kind of your DevOps tool of choice, then you're going to have a better understanding after this video, and you can integrate it with different services or cloud providers you might be working with. So let me share my screen really quickly, and we'll spend just a few minutes diving into what IaC is, and then specifically Terraform versus CloudFormation, when to use what, because we've kind of introduced both features in this series. So first, in terms of IaC itself, right, and I'll explain this in a data scientist angle, and then I think DevOps engineers especially will be pretty familiar with this tool. As data scientists, when I first learned, a lot of it was in a Jupyter notebook. I would have a notebook and I would have my ML model and I'd maybe train and then maybe I'd deploy and maybe there was some sort of data prep in the beginning too, and then maybe I added some sort of monitoring, right? This is all great in terms of learning and especially theoretically learning something, right? Like if you're learning about pandas, scikit-learn, TensorFlow, or anything of that sort, model building for the first time, Jupyter notebooks are a great place. I still use them to this day. And even for prototyping or showing some basic like new APIs or things that you might be working with, it's great. But the problem is retaining all of this and putting it in a production environment is difficult. Because in reality, we're going to have whatever variables or model metadata saved on this or model architectures, but we need to be able to port this over along with the appropriate infrastructure into a real production environment or setting. And you can't really just execute Jupyter notebooks always, and that's why you'll see in a lot of these OSS Python APIs, right, that are implemented, there's not really notebooks. There's just files and things of that sort that are properly kind of like laid out and compartmentalized and have a structure that you can properly deploy and use. So Jupyter Notebook is great for experimentation, great for understanding and testing, but in reality, right, the real power comes in being able to streamline this. And a large part of that is also DevOps, where we can actually consolidate all of these different steps into a singular place. So for example, in training, maybe you used a certain GPU instance, and maybe for deployment, you used maybe a certain CPU instance, and maybe for monitoring, you have some other hardware or resources or some container that's orchestrating your monitoring, right? And this is just a complete new example here. All these different variables and resources need to be saved and understood. So the cloud does the first part for us because these EC2 instances are really just virtual machines that are encapsulated that we can work with. But even then, these cloud resources, so these different kind of hardwares or containers that we might be working with when it comes to something like SageMaker or any other ML frameworks, we need to kind of encapsulate them in a single place that we can iterate over. So oftentimes there's been tools where you can have templates basically, where you can essentially say, hey, I want to create a SageMaker endpoint. This is the container, for example, that I'm using. Here are my hardware resources. Or maybe you have, hey, here's a training job that I'm executing. These are the services I'm using, maybe SageMaker or Bedrock. And then here's my metadata for executing that. So basically I'll have all the same variable values and everything, but you can basically streamline all of this into a singular kind of template or resource file almost. And apologies for the horrible handwriting as always, but right there, you can have a central kind of template that you're working with. And the reason this is so powerful, right, is you can come away from these kind of standalone notebooks, which when isolated really don't carry that many value, and you can encapsulate all your resources here. And especially when it comes to kind of iterating and when you're working on a team, This makes iterative development a lot easier because you have all your resources that you're working with allocated in a singular place, and you can understand and update that directly. And in the specific tool we talked about before this, right, is CloudFormation. And with CloudFormation, this is specifically for AWS. You can provide JSON or YAML template files, basically, that kind of provision these resources, and then any other metadata that you might have with them. And that's really, really powerful once again when it comes to DevOps and you're streamlining this. So in a real world production setting, right, you will see that every DevOps team has some sort of IaC setup for the most part. So CloudFormation is really powerful internally within AWS, right? But another key kind of option, and this is called Terraform, which is what we're going to be inspecting today. And you can see HashiCorp is basically the company that provides this feature or service, basically. And here within Terraform, right, the reason we're introducing this versus CloudFormation is another thing that happens with a lot of real world companies or users is you might be multi-cloud or multi-provider or provider agnostic. And you'll see this with use cases such as, I'm using Llama, I'm actually not fully sure, so fact checks this. But Llama is an open source model, right? But you can deploy it to multiple different cloud providers, such as AWS, such as GCP, or anything of that sort, right? And if maybe you're building your own application and maybe you have your VMs on EC2, maybe you have your database on Azure that you're working with. I don't know Azure database service because I haven't worked in there much, but maybe you have your setup like that, and maybe you have your LLM on GCP, right? When it comes to multi-cloud, you need an IaC provider that can work with multiple resources from multiple providers. So anytime you have a multi-cloud type setup or anything of that sort, whether it's you're just serving a model across different environments or things of that sort, or your application just has different components in different areas, that's where Terraform becomes really, really handy and differentiates itself from CloudFormation. CloudFormation is internally within AWS and focuses mostly on that. There is ways you can access third-party tools and services, but by default, Terraform has these constructs for different kind of cloud providers that you might be working with. And within Terraform, right, we will dive into this more. There's really two core constructs, and obviously there's more kind of niche language that we can get into in terms of understanding it. But all you need to understand at a bit of a high level for today, right? The two core constructs are variables and resources. And we kind of visited this in CloudFormation itself. This was called parameters in CloudFormation, and resources, I think it might be the same name. I'm honestly not rolling off the tip of my tongue there. But if we see here within variables, any hard-coded values you might have, and we'll explore and inspect this in a second, you can kind of capture in these variables. And then resources are the actual kind of things that we might be working with. So for example, since we're working with SageMaker in this case, this will be our SageMaker model object. And I encourage you to revisit, if you're new to SageMaker deployment, the pre-trained scikit-learn deployment, which we funnily enough did in a notebook. But this is us kind of mapping it into more of a production type setting using an IaC tool. So that it might be the model object, it might be the endpoint configuration, and then the endpoint. If we remember, all three of these are kind of interconnected in terms of what we're working with right here. So yeah, that at a high level is a bit of a kind of recap in terms of what infrastructure as code is and where you can use Terraform versus CloudFormation. Now what we'll do is we'll directly hop into Cursor, where we have these files, and all these examples are in the Git repo again, once again right here, where we're cataloging all this in this inference video series. So you can also clone this and feel free to follow along as you want. But if we come here into Cursor, we will see that I've also already ran this, and I'll explain this in a second. We'll see that there's a few setup files that you might actually realize if you've been following along, in this playlist. I have a local model. Our use case, once again, is taking a pre-trained scikit-learn model and deploying it on a SageMaker endpoint, right? This local model, if I execute this first, basically, I'm going to create a serialized model artifact, this model.joblib. This is just representing the metadata or the model data, basically, for a trained linear regression dummy model that I'm working with. I then have a few tertiary files that you should execute. And these files are basically going to create, number one, this create role. We'll create the SageMaker execution role. This is basically what lets us invoke the endpoint, create the endpoint, and gives you SageMaker and S3 full access, basically. So this will create our IAM role, and this is a construct that we need to deploy a SageMaker endpoint. And then we upload these model artifacts. The serving engine we're using is DGL serving, kind of like we covered in that pre-trained scikit-learn image, or pre-trained scikit-learn video that we were working with. I create my tarball. This model tarball, as we recall within SageMaker, captures all of our model artifacts. It's going to be this model.joblib. It's going to be our inference serving script. You don't have to mess with this at all. This is just your inference serving logic with any pre and post processing code. And then our serving.properties and requirements.txt, which are just files that you need to work with DGL serving. Like I said, if you want to get a little more in depth, go to the pre-trained scikit-learn video that's in the beginning of the series, basically. And if we see here, right, we're just going to create this tarball. We're going to push it to S3. We have two core things that we're going to need, right, to create a SageMaker endpoint. We're going to need the model data, and then we're going to also have our IAM role. And there's actually a third thing, which is the container image, but we won't introduce that in here. We'll work with that directly in the Terraform template itself. So after you ran these three files, make sure you go with local model first and then create role and artifact upload. We can then go over to our Terraform template. And if we see here, this .tf file, and I also recommend in Cursor, VS Code where we're working, just install the extension. I think there's a HashiCorp extension that will let you kind of have this highlighting and syntactical understanding basically of Terraform itself. But once you've installed that, right, you can come here and you'll see this is very, very similar to CloudFormation. The syntax is just a little different to fit the Terraform language basically. So if we see here, I'm working right now in IaC 1. I'm going to specify my IAM role that I created. In that create role.py, you'll get a IAM role outputted by default. Just copy and paste that here to reflect your own. Once you have that, we specify our container image. These are our variables, right? So this is the things that we had hard-coded in the Jupyter notebook, but we're basically kind of putting here. And you can see how powerful this is because let's say you have a container image update, or maybe you've updated your role or something of that sort. It's as simple as just plugging it in here, and it's central for everyone to see that's working with this template. So if I come here, I'm going to specify the DGL container image, which is our serving stack that we're using. And then the other variables I'm going to specify here is my model data, which we did with that artifact upload.py. That's our model data in S3 that we're working with essentially. And then finally, what's the instance type for my real-time inference that I'm deploying? If you have serverless, for example, or a serverless deployment mode, you don't need this instance type. You can just have the serverless configuration. Same with something like async or things of that sort, right? So essentially here, all I'm doing is I'm going to specify these four different things as variables. And this is very similar to kind of that parameters tab that we had within CloudFormation. So anything that you would traditionally hard code enclose in these variable parameters right here. And if I come here, right, this is just us revisiting our SageMaker core constructs that we've been working with. We're first going to have a SageMaker model object, which once again points towards our container image and our model data. And you can see you can reference that with that var or variable tag basically. So if you do var dot, that's the syntax within Terraform. You can point towards the variables that you've defined here basically, and you'll be able to access them. Here in this case, we point towards the container image and model data, and we can set up our environment as we need, just like we would in that create model API call as we've discussed. Tag it if you need any tags for that model object. And then the next resource we'll be creating is our endpoint configuration. And here I refer to that instance type. And also if you have any production variants or doing maybe some sort of A/B testing, you can also catalog that. And then the last resource we create, right, is our actual endpoint. And this will take a few minutes to provision. But before we go into like the CLI and how this all looked, you can see there's really only two main things that you're looking at, the variable and the resource, which is very, very similar to what you might expect from basically CloudFormation, but you just have to kind of adopt the syntax of Terraform itself. And the key thing here is, right, we're specifying that this provider is AWS. But if you have multiple providers, and maybe we can dive into this later too, you can pretty simply kind of point towards these with multiple Terraform files or kind of point at each other basically. And that's something we can dive into, but here you can see the whole kind of cloud provider agnosticity that we were talking about. I don't know if that's a word or if I made that up, but essentially you can use whatever provider you want. So those are the three different kind of things that we're specifying, but in reality, all of the crux of what we're doing is in this variable and resource tabs right there. And then to execute this, I included these instructions as well in the Git repo as well, so you can follow through that end to end. But really all you have to do is first a Terraform init, and that will initialize this. And this is also in the Git repo right here. If we come here, a Terraform init initializes a Terraform project basically, and then a Terraform apply will deploy your resources. So if you see here, you will get this in the CLI itself saying that these are the resources actions that we're going to be taking. First, we're going to provision a SageMaker model object, and then the endpoint configuration, and then finally the endpoint, the kind of that chain that we've always talked about and referred to here. And you'll see that it will plug in the necessary kind of variables that we were talking about directly in for us. So it will synthesize and do that for us. And once you give authentication to kind of perform these actions, you'll see this might take a few minutes to create. But if we go to the console, our AWS console, our SageMaker AI right here, you'll see that I have a SageMaker endpoint sklearn TF created right here. So very simple process end to end, very similar to CloudFormation, but very, very powerful at the same time, especially when you're working in a multi-cloud type project. But yeah, at a high level, that's mainly what I had for today. Make sure to also delete your endpoint just to avoid any costs, because remember, for real-time endpoints, you can incur costs. But yeah, any questions or any doubts, please leave down below in the comments as always. I hope this video was useful for anyone who's working with Terraform or SageMaker in terms of getting started with this project. We'll be back with more in the SageMaker AI space. There's more and more stuff coming with LLMs. I know lately my focus has been kind of Bedrock strands, but you can still use SageMaker very effectively in the ML and Gen AI space. So we'll continue to cover a few of those different things. A bit of a sneak peek, I guess, is we'll talk about something like bring your own container in future videos. But yeah, we will get to all of that shortly, and I will be back very, very soon. If you enjoyed the video, feel free to leave a like and subscribe. Thank you as always for watching, and I'll talk to you guys soon.